Alright, let's learn about the basic tools of graphing. And we're going to graph in the Cartesian plane, named after René Descartes. And it extends forever in the x direction, both positive and negative, and in the y direction, both positive and negative. So you'll notice that x is horizontal and y is vertical. This is called the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. How do we plot points? Well, every point is an ordered pair, and the first number is the x coordinate and the second number is the y coordinate. So if I'm going to plot the point -1, -4, I'm going to go back 1, down 4, and there's my point -1, -4. 2, 2, that's going to be +2 in the x direction, +2 in the y direction, and there's my point 2, 2. -2, 3, I'm going to go back 2 and up 3. There's my point -2, 3. 0, 5, so this means I'm not going anywhere on the x-axis. That means I'm stuck on the y-axis. There's my point 0, 5. And finally, -3, 0. I'm not going anywhere in the y direction, so I'm going to be on the x-axis, and I go back 3. So there's my point, -3, 0. Okay, let's find the distance between 2 points. So let's say that I have a random point here, which I'll call x1, y1. Then I have a random point up here, which I'll call x2, y2. And the question is, how far apart are those 2 points? What's that distance d? Well, what if I went straight across from x1, y1 until I was directly beneath x2, y2? Then this would have coordinates x2, y1. It has the same x coordinate as this point and the same y coordinate as this point. That means this distance is going to be my change in y, y2 minus y1, and this distance here is going to be my change in x, x2 minus x1. And we've created a right triangle, so guess what? We can do the Pythagorean theorem. So d squared, the hypotenuse, is the sum of the squares of the legs. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. And to solve for d, we'll get the square root of all that. Okay, so what have we just figured out? This is called the distance formula. And to get the distance between 2 points, I subtract x coordinates, square, subtract y coordinates, square, add them together, and then take the square root. So here's the distance formula in a nicer looking version. And we're going to get the distance between these 2 points here. So this is x1, that's y1, this is x2, and that's y2. So here we go. The distance is the square root of -3 minus 5 squared plus 7 plus a -2 is going to be, 7 minus a -2 is going to be 7 plus 2 squared. Okay, that works out to the square root of 8 squared plus 9 squared, which is the square root of 64 plus 81, which is the square root of 145. So that's the distance between those 2 points. And finally, let's look at the midpoint formula. And I like to think of the midpoint formula as just averaging the x coordinates. So I'm going to add x coordinates and divide by 2, and averaging the y coordinates. Add the y coordinates and divide by 2. So here we've got 2 points, 2, 6, and 4, -4, -2. And here is the midpoint. The midpoint between them is going to be the average of the x coordinates and the average of the y coordinates. And that's going to give me -2 over 2 and 4 over 2, which works out to -1, 2. Let's graph them real quick and see if that makes sense. So here's -4, -2, and 2, 6. There's a segment between them, and we calculated that the midpoint would be -1, 2, and yeah, that does look like it's halfway up that segment, so it works.